Welcome to the Helix webinar series. Today's session is on BMC Helix ServiceOps. We'll be covering ITSM and ITOM. It will be on-premise deployment disaster recovery support. I've got three special guests. We have Nisha Faisal, our Director of Product Development. We have Krishna, our Principal Product Developer, and we have Rajan, our Principal SQA Engineer. Each of them will be presenting parts and demos today. But before we get started, I've got a couple of reminders. We will be putting you all on mute to start with because we have about an hour's worth of content. So for those that have got questions, please put them into the Q&A section. We do have a large set of panelists that will be answering those during this webinar, which is being recorded. And then we will also have some time at the end if you want to stay on to ask some questions live to our panelists. So just before we get started, when you're registering for this event, we will be sharing this out on YouTube. We will be sharing it on our social media platforms. So if at any point that you do want to talk at the end and you need to change your profile name, please put it to anonymous. Otherwise, we will be recording and sharing this content post-event. We will be sharing the slides out. We will be sharing the Q&A and we'll be sharing the recording. So without further ado, I'm going to hand over to our first presenter, Nisha, to get started.
Thank you so much, Sam. Hey, hello, everyone. It's great to be part of this webinar. This is a feature which I know it's long due. There were multiple requests for this feature, and we are very proud to present the feature to you, the BMC Helix Disaster Recovery. So let's quickly look at the agenda for today. One, we are going to give you the overview of the BMC Helix Disaster Recovery feature. We are going to help you understand how to prepare for a disaster, how to recover from a disaster. We are going to share with you a few tips, which is going to help you while using the feature, followed by demos, 2 demos precisely, one for ITOM on how to use this feature for ITOM customers, and second one would be to use the features for the demo to use the features for the ITSM customers. If time permits, we would definitely love to have a Q&A session as well with all of you. Okay, now let's jump into the overview section. So even before we start talking about the feature per se, let's talk about what is a disaster. So as all of you know, a disaster is an event which disrupts the normal operations of an organization. A disaster could be a power outage of your data center. It could be a breakage of the systems, a failure of the systems. It could be natural calamities. Whenever a disaster occurs, it is very important for every organization to recover quickly and resume their normal operations with minimal, in an ideal scenario, with zero impact. So what is the role of this feature? How does this feature help? In an unfortunate situation where a disaster strikes, and if your BMC Helix systems are down, that is where this feature is going to help you to recover very quickly and resume your normal operations with minimal impact. This feature is going to cater to all types of BMC Helix deployments, a pure ITSM deployment, a pure ITOM deployment, and even a ServiceOps deployment, which is nothing but the ITSM and ITOM Helix combined deployments. At a very high level, our disaster recovery strategy is based on an active-passive replication, employing a backup and restore methodology. By that, what we mean is that for the disaster recovery process to work, we want a secondary site or a passive site to be set up, which should be very identical with the active, the primary setup. And then we want all the data in the primary to be regularly backed up. Now, what is the kind of data that should be backed up? All information which is required on a later day to restore the current system is the information that we want to back up. Say for an ITOM customer, you know all the important information that you have, right, which you are storing in your data lakes, your events, logs, metrics, your policies, configurations, tenants, users. For an ITSM customer, all your important FTS indexes, all the data which constitutes your system, which is required to recover your system, has to be backed up, and that will have to be restored seamlessly and quickly to make sure that your normal operations are resumed in no time. So that is the overall high-level disaster recovery philosophy or the strategy that we have in place. Now, let us see what needs to be done to prepare for a disaster. So let's get the premise very clear. The premise is that already you have a primary site. You could be an ITOM customer, you can be an ITSM customer. You have your primary site up and running. That's the premise that where we start. Now, there are a few steps which are required to configure the setup for disaster. Now, please pay a close attention to this dotted black line. Okay, for any ITOM customers, you need to follow the steps which are portrayed on the above the slide. But for an ITSM customer, since you should be equally bothered about the disaster recovery of the Helix platform common services, which gets deployed through the deployment manager, you need to worry about all the steps above the line and below the line. Now, what would be the steps? So if you just remember the slide before, you could remember that a disaster recovery mechanism involves creation of a secondary site. We need to have a backup, and we need to ensure that the restore happens seamlessly. We need to create that kind of a setup. Now, how do we do that? Step number 1 is creating a secondary site and scaling it down. We have to do it both for ITOM and as well as for ITSM system. That's a step number 1. Step number 2 involves configuring backup in the primary site. And step number 3 involves a data replication. Now, why is a data replication involved? As I mentioned earlier, it is very important that whenever a disaster happens, we should be able to recover the data very quickly. So until and unless the data is brought very close to the secondary site, it will not be possible. So that is where the role of the data replication comes in, right? Wherein we are trying to bring the data from the primary to the secondary site and keeping it ready there. So now let's get into the details of how each of these steps work. So step number 1, setting up the secondary site. So few things are very important when you are setting up the secondary site. Most important thing is that the site should be identical. Anything that when you are constructing the secondary site, it should be identical to the primary site. All the configurations should be identical. The product version should be identical. You should configure the same namespaces and same URLs. Only exception is the Minayo URL should be different between the primary and the secondary site to support the DR functionality. Other than that, everything should be ideal. And you need to keep in mind that it is not just a one-time thing that we are talking about, right? Even once the secondary site is set up and over the period of time, when you're making changes to the primary, you might be upgrading the primary, you might be applying hot fixes, you might be changing configurations. Please make sure that as part of that upgrade process itself, you apply the same changes to secondary as well, so that at any point in time, site should be identical. Now, for the ITSM customer, please make sure that whenever your data is in the external database, and please make sure that you have the same DB alias name for both databases, primary and secondary. Now, in order for you to set up the secondary site easily, we have come up with a few tools. We are shipping the tools along with the installers. So on the step number 1A is setting up the ITOM, this mainly for the ITOM customers and as well as for the ITSM customers when they have to set up the Helix platform common services. As you are familiar, I hope you guys are familiar with the deployment manager, which is the installer which will be used to set up this part of the ServiceOps suite. So you select the necessary options and run the deployment manager, which is going to bring up the ITOM part or the common services part of the deployment. Now, once you have done that, this scaling down step is completely optional, but we would like to recommend it predominantly because if you don't want to keep the resources running, you can always scale it down. And for you to scale it down, there is a utility that we are shipping. So if you go to the deployment manager, there is a folder called utilities. Under that, you will find a subfolder called disaster recovery. Under that, there is another folder, DR scale. There is a script file, product_scale. You just run the script with the option down, which is going to scale down the pods which are deployed. That is step number A, wherein you got it ready for the ITOM customers or for the Helix platform common services for the ITSM customers. Now, for the ITSM customers, what we have done is, along with so ITSM deployment happens through Jenkins pipelines. This time we have released a new pipeline, Helix DR pipeline, specifically to cater to the DR capabilities, DR deployment. So all that you need to do is run the Helix on-prem deployment pipeline. And the thing that you need to keep in your mind is that in the product deploy section, it is very, very important. Select Helix DR scale down option. This is very important because when you are deploying and if you want to run it in a scale down mode, select the scale down mode and then select the Helix generate config and trigger the deployment, right? So that is going to ensure that you will be able to complete the deployment and scale the pods down as needed. So this is step number 1 completed. At the end of the step number 1, we have the secondary systems deployed, but then in a passive state where the pods are not running. Now let's move to the step number 2. Step number 2 is all about configuring the backup in the primary site. So how do we configure the backup in the primary site? First of all, the backups we are going to store in Minayo. Minayo is going to be our storage for backups. And there is something which is very, very important that you need to keep in mind. And this is more like a prerequisite. For the Minayo, sufficient space should be allocated for the Minayo PVC. Right? That is a very, very important prerequisite. Second important prerequisite is that use storage drivers that support volume expansion. So our recommendation would be Ceph, but then this is also something which is non-negotiable for DR to work and for the RTO and RPOs to be intact, right? So with these prerequisite sets, we are all set to configure backup. There are only 2 simple steps to configure backup. What are they? First step is, there is a config file, which is again getting shipped through the installer. You can find it under disaster recovery under the config folder. There are 5 parameters in the config file, which needs to be configured. Once you configure it, then just run the magic command, disasterrecovery.sh with the option backup. This is all that you need to do to configure backup in the primary site, and the backups would be triggered. Okay. Now, for you to understand, we feel that it is very important for you to understand a little bit more about how the backups work so that you can configure the values properly and avoid any future mistakes. So for that, let's take a closer look at how the backups work. When you configure the file and when you trigger the backup, run the command, behind the hood, right, inside Minayo, something changes. What happens is that based on your configuration, there is a bucket which gets created, and under the bucket, there will be some folders which will be created, which will be holding the backups. Now, let's take a closer look at the bucket. This is the first bucket which would be created, and this bucket, the name of the bucket is something that you will be configuring, and the purpose of this bucket is to hold the backups. Under the bucket, you will find a folder which corresponds to the site name. Say, for example, you are now configuring the backup on the primary site, and for example, your primary site is in India. So it is good that you configure the site name as India. So at any point in time, it will be easy to figure out from where the backups have happened, right? So this is the name of the site from where the backups are gathered. And then under which you will find multiple folders, each folder corresponding to the component which is getting backed up. So you will find folders for Elasticsearch, for Postgres and whatnot. And under each folder is where our actual backups gets created. So our backup strategy is that every day on a daily basis, we will have one full backup followed by multiple incremental backups. And those incremental backups would be configured based on the interval that you're configuring in the config file. Right? So this is what happens when you configure. This folder structure will be created, and this final thing would be blank when we configure it. Now, let us take a look. Yeah, let us take a look at the config file. So here you can see that there are, as I said, there are only 5 values that needs to be configured. What is the first value? It is bucket name. Here you can see that the bucket name is where you configure the name of the bucket, which is going to hold the backups, right? The Helix DR backup, whatever you see here, is based on what you had configured here. Second one, as I mentioned, it is a site name, which is the name of the site, which is going to gather the backup from where we are gathering the backup. So here we have configured India. That is the reason why you can see here India. Third one is the namespace, right? The namespace where you have installed your BMC Helix IT Operations Management or Helix Platform Common Services. When you, this is the namespace which you use during the installation. That namespace is what needs to be configured here. Before I move on to the fourth parameter, let me give you a little more insight on the backups. So assume that you are going to configure and trigger the backup at 9:15 a.m. in the morning, right? So please understand that the moment you configure and trigger, the backups are not going to run, right? First of all, and then this activity is only going to happen once in the entire lifetime when we are first initially configuring the system for backup. The system might take up to 30 minutes max to configure the system for the backup, or for the backup configurations to be effective. It would take a max of 30 minutes. Why is it taking so much time? Is because as part of this setup, there are all these components, right? Elasticsearch, Postgres, Victoria, Metrics, Mnaio, all of them would be changed. Their pod definitions, there are slight changes which happens. There are some cron jobs which gets created and associated, and then it would warranty a restart of these services, right? And behind the hood, as I mentioned, inside Mnaio, all the folder structure, the bucket and the folder structure will have to be created. So a lot of backend processing happens as part of triggering the backup. That's the reason why there is a 30 minutes delay. So then you would assume that, okay, 9:15 I have triggered. So 9:45 it has to start, right? It's not going to start at 9:45. What the system does is it will always round up the time to the next whole hour and start the backup there, right? So even if you have done it at 9:15 or 9:30, it is going to start only at the next whole hour, which is 10 a.m., right? And the first backup that will be triggered will be the full backup. So one thing what you need to understand about the full backup is that, as you can figure out commonsensically, full backup is going to take it is going to deal with more data backup, and it's going to take more time. Our performance test lab results has not proven any performance degradation in the actual system when this full backup happens, but we would like to err on the side of caution. So what our recommendation would be that whenever you are starting a full backup or whenever you are triggering the backup for the first time, make sure that you trigger it at a time contrary to what I have specified here. Choose a time which is the lean time, right, where the less activity happens. So, so that is one tip for the triggering the backup or the time that you have to choose. Now comes this DR backup interval in R, right? Based on the value that you have configured here, this is in hours, right? This is a backup interval in hours. What would happen is that in regular 2 hours interval, post the full backup starting, the subsequent incremental backups would also will get triggered. So what that means is that the first backup would be triggered at 12 a.m. and after 2 hours, again, the next backup would start. And finally, at the end of the day, right, the next day after 24 hours, we will have another full backup starting, right? So this is how it works. We will have a daily one full backup, followed by incremental backups, multiple incremental backups, scheduled at a time interval which we have configured in the config file. Now, the last parameter that is of importance is the DR max backup to retain. That would specify the number of days that you would like to retain the backed up data. Say, for example, if you say that the backup data retain is 1, it would retain after every 1 day, right? It would clear the backups which are created, right? So this would ensure that your storage is not filled up unnecessarily, and then you will have you will have only the right amount of backups in store. So that is about the backup configuration. Now, the third thing, as I said, now we have the secondary side, we have the backup, but we need to make sure that the backup is made available at the secondary site so that whenever a disaster happens, quickly we can restore it, right? So you know that the primary site, we are storing the backup in Mnaio, and in the secondary site also, we are going to store the backups, whatever we have in primary, we will make it available in this secondary Mnaio so that restoration is easy. Now, the way we are going to do it is by leveraging the out-of-box Mnaio to Mnaio data replication. Mnaio provides that capability. It is an industry-wide replication best practice. So we are adopting that for our data replication. Now, one thing to keep in mind is that in order to do the replication, right, there are two steps. How do we configure the replication? So in order to configure the replication, first what you need to do is you need to go to the primary Minayo web console. And there you can see that already the backup bucket would be created. It is very important that all the buckets which are participating in the replication has versioning turned on. So all that you need to do is step number one is go to the primary site Minayo, enable the versioning for the primary site, for the primary bucket. Now go to the secondary Minayo. Here you have to create a bucket, right? Because the bucket is not created. And after creating the bucket, you will have to enable versioning for this bucket as well. That's step number one. Step number two is to make sure that you configure a replication rule to ensure that from the primary Minayo to the secondary Minayo, the data gets replicated. So it's a very simple step. Rajan is going to help you with the details during his demo, but just configure the replication rules in the primary Minayo and you are all set. Now, one thing to remember is for ITSM customers, please make sure that your bulk of the data is present in the external database, and it would be the responsibility of the customer to make sure that there is the DB data replication is configured and intact, right? So that is something that the customer has to take care of. So with this, right, I guess our system, if we follow all these steps, we created the secondary site and we are with the backups ready and with the data replication in place. Now we are all prepared for the disaster, right? Now let's see when a disaster strikes, what is that needs to be done. So again, the premise is we are ready for the disaster and the disaster has happened. What is that needs to be done? Again, there are a set of steps for ITOM customers. Please worry only about the steps that are given on top of this black line. For ITSM customers, you will have to take care of all the steps which will be outlined here. So let's see what are the steps involved. Step number one is remove the data replication. So if already the Minayo to Minayo data replication is in place and we know that, and there is a way to access the primary site, remove the data replication so that there is no possibility of a data corruption. Second step is, yes, we want to now we have our secondary site. We need our secondary site to be the new primary or to be the new active site. For that, if the secondary site which we have scaled down, we have to scale it up and give it life, restore it, right? Restore the data. Already we have made the data available there, just restore it. The fourth step is all the DNS entries now should point to the secondary cluster so that the routing happens to the secondary cluster instead of the primary cluster. And for ITSM customers, conditionally, there might be a need to reindex FTS, right? So we are going to discuss about all these steps again in detail. First step, removing the Minayo to Minayo data replication. So as I was mentioning, that there is this replication configured if there is a way. So I'm just repeating, whenever the disaster happens, it depends on the impact of the disaster. Maybe there is no way to access anything in the primary. If that is the case, the step would be an optional one. We can't even access the primary, so we can't turn it off. But if there is a way to access it, please log into the primary Minayo web console and revoke that rule for data replication. Now, step number two, we need to scale up the secondary site. So in order to scale up the secondary site, again, we are offering the tools. Now, there is one tricky thing which I have done. See, step number 2A, even though I have a step number 2A here, which is meant for scaling up common services and ITOM, this is blank, right? This is because the step number 3, which is basically giving life to the secondary site or restoring the data, also takes care of scaling up. But just to make sure that the flow is cleared, I had mentioned this as a step 2A. But actually, step 2A and step 3 would be taken care in step 3 itself for the ITOM side of the house. And for the ITSM, what we need to do now to scale up is, again, the same thing. You run the Helix on-prem deployment, select, but this time, please make sure that the scale down is unselected, right? And then you just trigger it. It would take care of scaling up, right? So now we have the secondary side, which is up and running. All the pods are up and running. And then we move to the step number 3, which is data restoration in the secondary side. The data is available in this secondary Minayo. We need to make sure that the data is restored in the secondary side, which is up and running. For that, again, the steps are very similar to how we configure backup. There is a config file. It's the same config file which we have inspected in detail earlier. In the config file, make some entries and then again run the magic command, wherein this time we are going to run it in the mode restore. Last time, if you remember, we ran it in the mode backup. This time we are going to run it in the mode restore. Now, when we inspect the config file, right, it's the same config file, you should remember the same entries. Here, the bucket name should be the name of the restore bucket, right, which is there in the secondary site. Now, please understand this point. The site name should be the name of the site from where you want to restore data. So in this case, from the India site is what we want to restore. So this is the name of the site from where you have to restore the data. And again, as you know, the namespace should be the namespace which you have installed, the BMC Helix IT Operation Management or the Platform Common Services. And please recollect the mandate. The namespaces should be similar. So it's the same namespace that you will have to give. The other 2 options are not applicable due to obvious reasons, right, in this particular scenario. So how does the restore actually work? If you look into the bucket, right, you will see all the backups, right, based on the intervals that you have configured, based on your retention values that you have configured, all the backups would be present here. What the system does is it looks for the last successful backup and then it restores it. On top of it, it would add all the successful incremental backups as well. It is as simple as that, right? So that is how we do it. So now we have the secondary system up and running. We have restored the data, right? Now the next thing is to make sure that all the DNS entries are pointing to the secondary side. So and also for ITSM customers, please make sure that the DB the DB alias name is also pointing to the DB host in the secondary cluster. That is something which is very important to remember for the ITSM customers. Now, the last step is FTS reindexing. It's an optional step. See, as you guys know that in the Elasticsearch, right, for the full text search indexes would be stored. And you know that in the secondary site, in the secondary Minayo, based on Minayo to Minayo replication, you will get all the snapshots which are there for the FTS indexes in this particular Elasticsearch. Now, the thing is that assume that this backup ran at 2 p.m. and we have the snapshot as fresh as 2 p.m. Assume that, and then, but for the DB, right, you know that the replication strategy is different. It can even be like no instantaneous replication. If the disaster happened at 2:30, right, the DB can have as relevant data as 2:30, but you can see that the FTS indexes in the Elasticsearch will be as relevant as 2 p.m. So there would be a difference between the data or there is a need for a delta reindexing to be done. In order to do that, what you need to do is that this is something which should be familiar with you. There is a feature in Mitair. You have to access the AR system management console. In the FTS management, there is a provision to do a reindexing. So please make sure that depending on the delta reindexing that you need to do, select the appropriate time and do the reindexing. So that concludes the steps required for recovery. Now, I would like to share a few more tips with you guys while using the feature. Tip number 1, due to any reason, right, if you want to disable backups, again, we are helping you with the tool. This magic command, disasterrecovery.sh, this can run in the 3rd mode, which is the disable mode. So when you run a disable, it would be disabled. Anytime you want to enable it, just run it with enable mode. When you disable it, you would get to see the successful command on you will be seeing this command on successful disable execution. Now, how to validate whether backups are configured properly? There's a step which we would recommend you to do, right? So So there are two things that you have to do to ensure that backups are properly configured. First thing is that whether the cron jobs which actually carries out the backup, are they configured properly? We need to validate that. For that, go to the controller, run this command. And if the output of your command is something like this, wherein you can see that all the backup cron jobs are running and it is as per the schedule that you are configured, give a thumbs up, your cron jobs are scheduled, configured properly. Now, the second thing is that don't stop there. Go to the next step, wherein you can go to access the Minayo web console. From there, open the backup bucket, or access the folder. From there, there is a subfolder called backup status. You will find a log file there. Inspect the log file and check for the presence of the errors. Now, how do you know whether there are errors? This is how typically the backup, this is the snapshot of a successful backup. This is what you should be seeing, okay, if there are no issues, wherein you will see the start time, end time of the backup. You will see the message that yes, it has completed successfully. The components which have been succeeded would be listed here. Any component which has failed, the details would be provided here. Any component, any backup which was timed out will be provided here. The lower section here, it's kind of a little gibberish. This is more to help you whenever, due to some situation, if your backup is failing and you want to reach out to the support team, right? This piece of the information would be beneficial for the support team to troubleshoot better. So this is more, this data is going to come handy at that point in time. Now, another thing what we have done is we have added support for built-in backup monitoring. We will be continuously monitoring the backups, and on the event of any backup failure, a notification email would be sent to the tenant admin. So what this means is that, so this is the sample notification email that you would see on the at the event of a failure. We are not sending any success emails. We don't want to clutter your inbox. Only during failure we would see it. And similar to the log content, right? You will see the start time and the end time, and then you will see that for which all components backup succeeded and which all components the backup failed. And again, the text which will give us more details at the time of troubleshooting. Another word of caution is that due to some network glitch or something, right? Maybe there are momentary glitches and then failure might happen. We do have built-in retry mechanism, because of which we would be trying. So if you just get one mail, you need not have to bother. You can just access the logs and then confirm whether everything is okay. But then if you are getting a series of mails, then that is where you need to be worried about. And then please do the investigation at your end. If you are not able to solve it, please feel free to reach out to the support team, right? And this was the last step that I wanted to share with you. With this, I would like to hand it over to Rajan for the ITOM DR review demo. Thank you so much.
Yeah, thank you, Nisha. Let me share my screen for ITOM DR on-prem demo. Let me know once my screen is visible.
Yes, it is.
Yeah, thank you very much. So we want to configure the DR backup on a primary site. So we need to have the installer ready with us. Right, so this is the installer I have with the primary site. I go with Helix on-prem deployment manager, utility, disaster recovery. I need to configure the config file, which is with dr config. So there are a couple of parameters like bucket name, where the data will be backed up in a Minayo, site name. Then we have the ITOM namespace, which we need to specify. Backup interval, that is in hours from 1 to 24. And the retention period, this is in days, right? Underneath parameter, it is for internal purpose. We do not ask to change anything underneath. So that is for the configuration part of it. Then we want to run the backup. In that case, we need to say disaster recovery and backup. As it takes 30 minutes of time, I just have the backup done. So we will go through it, but otherwise, if you start this, it will start the backup process, and it will configure the backup, and it will start the actual backup at its given schedule. Backup logs will be in log folder of installer. So the backup looks like it will first go and check the pre-checks which is required for backup script to be started. Let me go there. Yeah, so it is the pre-checks. It will do the pre-checks. If there is any issue in the config file or in pre-check, it will error for that. We need to fix it and then move further. Once it is pre-check is completed, it will go and have the Victoria metrics. So in case of Victoria metrics, it is kind of the native tool which we are using with the sidecar approach in a pod. So it will add the container and configure for the backup. Then we have the other data lake component, which will start configuring the backup. The next is Minayo bucket. Minayo application backup things is done. Then it is Zookeeper. Then it is DRS repo. Then optimize Postgres. Elasticsearch for logs and events. And Kafka. ML model PVC. So by that, we understand that the configuration is going good. Then we have the whitelisted selected Kubernetes object backup. Once it is done, we can see that, the backup configuration is successful. Here you can see the data lake component wise successful backup message, and here is the summary. So it gives you the one level saying that the backup configuration is done. Right. The other thing is as per the schedule, once the backup is started, we can go and check the site Minayo, and inside that we can see that the DR backup bucket is created, the site that is created underneath it, and this is how the folder structure will look like. Now we are interested in backup status. We will go inside it. And for debugging purpose, backup.log, which is really interested. If we download that, how it look like? It shows you the backup start time and end time, the status of backup, if it is successful or any failure. Here are the areas where it says that these are the component is successful, these are the fail, and these are the timed out. Now, if you see anything in a timed out, it doesn't mean it is failed. It is something that there is a defined time to monitor it. It exceeded that, and that's why it is timed out. But it really doesn't mean that the backup is not done. We need to check it, why it takes longer time, but it doesn't mean it is failed. And underneath there is this events data. This is mainly the metadata for the debugging purpose. So this one entry is for one backup. We can see the series of entry for each backup interval. That's how it's useful. Now, in a case that you have some maintenance window, and if you want to stop taking the backup for some point in time, so there you can use the same with disable. Once you run this, it will disable the backup and it will not have the further backup until you say, if you want to start the backup again, then you need to say backup, and then it will start again. All right, let me show you how it look like when you disable it. So once you start the disable, it will go and pick your configuration, and based on that, it first disable the KTS object, then Elasticsearch, Kafka, the Zookeeper, Minayo, DRS repo, Victoria Matrix. In case of Victoria Matrix and Postgres, it has added the sidecar, so that will be deleted. And then once it is done for all other components, optimize AIOps, everything is done, then it will say the disable is successful for each data lake component, and at that it will give the summary message saying that the disable is completed for all. Once it is done, we know that the disable is done, and again backup can be started as and when it is required. The other part, data replication on the secondary side. So let's say we go to the secondary and we have created the bucket that is dr-restore. Then what we need to do, again, we come back to the primary Minio, and there the dr-backup bucket is there. We need to set the replication rule. We just go to the replication and we need to say create the replication. Add the replication rule. Here we need to give the target URL. Let's say this is my target, so that you can find it from the ingress also. So there are two ingress. One is for UI access, that is web access, and another is API. We are interested in API, so make sure that you provide the proper one. And then we need to provide the credential, that this is my credential, and the target bucket where the replication will start. So in our case, dr-restore, we give this and we say it as a save, right? Once we save it, it will start the replication. I have already done this to save the time. So in that case, let's go to the restore. And in restore, we can see that the site is already replicated. The data is there, right? When in case of disaster, the first thing we need to do is we will stop the replication, and then we will go for the secondary site restoration. The reason is, if there is some corruption on primary site due to disaster, we don't want to replicate those things also, right? So that we need to stop. And then for restoration, we go for the restore site, and here again it is the installer. And we need to go inside the installer Helix on-prem deployment manager utility disaster recovery, and let me configure the DR configuration file. For restoration point of view, we need the bucket where the data is there, and the data is with dr-restore, the site name, and ITOM namespace. Backup interval and retention argument are not really needed for restoration. It is just for backup purpose, so we are not interested in that. Once we start the restoration, in the first part of restoration, we'll scale down the application pods and then perform the data restoration, and then again scale it up. So it will take some time. So I have already done it. Let me walk through it. Yeah. So once we start the restore, again, it will go and check for the pre-checks. Once the pre-check is done, then it will go and scale down the product service. So it will go and scale down all the product applications. So it makes sure that there is no stale data. The scale down is still going on. Scale down is going on. Yeah, we can see that the scale down operation is completed successfully, and then it will start the actual restoration process. And here we can see that it is again installing the Victoria Matrix sidecar for the restoration purpose, so that the native tool will go ahead and restore the data once the Victoria Matrix is going on. Victoria matrix is done, then the Minayo application bucket restoration is started. Then the Zookeeper, then there is a DRS repo, then it is optimized data. We have the Postgres restoration going on, and then it kickstart the Postgres related things, and we have Elastic search logs, then it will be the events, Elastic search events, the Kafka. We have the ML model PVC restore is going on. Then we have the Kubernetes selective K8s object. Right here, we can see that the restoration is going on and successful for a couple of them. It will still keep pulling the status of restoration, what's going on the restore side. Once the restore side, when it all are restoration completed, then it will start on the scale up application parts. Right here, we can see that the individual component also that all are successful, and as a summary that all is completed, then the scale up process is gone started. So let's wait for that. Once the scale up is done, the scale up is going on. Scale up is going on. Scale up, scale up. Yeah. So once the scale up is completed, here we can see that the last is the successful completed of restoring, and the scale up of pods is. So that's how we get the confirmation that it is done. And in case if you need to run the scale up or scale down as an individual on the secondary site, it is the same path under DR scale. And for here, you can have the product scale script with up to scale up or down to scale down. All the logs of DR scale up, scale down will be there in the standard log folders, where you can see the logs in case there is a need of any further debug. Thank you very much for watching the demo. Let me hand over to Krishna for ITSM related demo.
Hey, thanks, Rajan. Let me share my screen, folks. Are you able to see my screen?
Yes, it's in Helix DR, is that correct?
Okay, yeah, thanks.
Okay.
Okay, hello everyone. My name is Krishna. I'm a technical lead in the Helix on-prem installer team. So today we will see the Helix DR pipeline, so which is used to set up the disaster recovery for Helix ITSM on-prem setups, right? So, this pipeline, the Helix DR pipeline, as Nisha mentioned already in our presentation, is what we use for the Helix, the DR setup for ITSM. And this pipeline comes along with your deployment agent setup, right? When the deployment agent is set up, so you know there's a bunch of pipelines, and the Helix DR pipeline is one of those pipelines. And what you see right now on my screen is an execution of this Helix DR pipeline. So like all other pipelines, we trigger the Helix DR pipeline from the Helix on-prem deployment pipeline, right? So this is our Uber pipeline, we call it, right? So from this is the primary entry point for the on-prem customers. So you just like, trigger any pipeline for ITSM deployment from the Helix on-prem deployment, right? So first let's look at the primary differences between the standard deployment versus the Helix DR pipeline. So as you all know, so you provide all the environment details in this on-prem Helix on-prem deployment pipeline, and for a standard installation, so you select different products that you wanted to install, and all the inputs as we have seen already in the slides, right? So we expect the secondary site to be identical to the primary site. So pretty much all the inputs in this pipeline for secondary site setup is going to be identical to your primary site, right? So now, quickly to see the differences between the standard deployment versus the DR deployment. So for standard deployment, you might be knowing, right? So we select generate config pipeline and the platform deploy pipeline, non-platform, and smart apps. So collectively, these three, so this generate config pipeline creates an env file based on the inputs provided in this on-prem deployment pipeline. And these three pipelines, platform, non-platform, and smart apps, these three pipelines collectively deploys the entire ITSM services, right? So this is what we do for a standard deployment. And so it's assuming that you already done on the primary site. Now, how do we run the Helix DR pipeline to set up the DR setup on secondary is the same procedure as we just saw. So input does not change, but the only pipeline is going to be changing. So we don't want the platform, non-platform, and smart apps. So for DR, as we just saw, so there's a pipeline called Helix DR pipeline. And so this DR pipeline, has runs in two different modes, so scale down and scale up. So we will come to that in a bit. So this is what we do. So to set up your Helix DR setup for ITSM, you just run this pipeline on the secondary environment, and just run this DR pipeline with scale down, right? So that's pretty much it. And so this to set up ITSM on the secondary or passive side, right? So this pipeline, when you run it in scale down mode, what exactly it does is it deploys all the Helm charts of the ITSM services. So which is otherwise deployed through this three pipelines, right? Platform, non-platform, and smart apps on the standard deployment. But now this one single pipeline has all those Helm charts required for setting up an Helix ITSM environment. It deploys all of those Helm charts with 0 replicas. That is, after you run this pipeline, once it is successful, if you go to your secondary site, ITSM namespace, and check the namespace, you will see all the Kubernetes objects like Helm charts and deployment, stateful set, config maps, and everything required for the ITSM setup, except the parts, because the the Helm chart runs the deployments for services with 0 replicas, right? So if you see here, so all the deployments are done on this previous execution, where the different ITSM services you can see, so ATM web service, catalog, catalog, and the DWP, AIS, Foundation, Meteor user, etc., all the platform parts. Right. So now let me take you to that installed environment. So if you see here, so I run the Helm LS, you can see the Helm charts deployed by the DR pipeline. However, if I run get pod, you're not going to see any parts in this, right? So let me run it here. So if you see the get part, so you're not seeing any parts in the namespace. That's because, as I said earlier, when you run the Helix DR pipeline in the with selecting the scale down checkbox, it deploys all the services without with 0 replicas, right? So if I get stateful set, you will see the OpenFire platform, all the stateful set with 0 replicas, as you see, right? And similarly, if I run this command for deployment, so you want to see the ATM web service, DWP, Meteor catalog, ITSM plugin, all of this. So the idea is we have all the objects deployed on the secondary namespace and keep it ready and all ready to start up when a disaster happens on the primary end, right? So that is when we come to the second mode of the pipeline. So I hope with this, once this is done, so your secondary setup for disaster recovery is complete. So your pipeline is done, and then the objects are installed on the secondary environment. So you're good now for all the secondary disaster recovery. So now this secondary standby setup of ITSM is ready, and it is ready to be scaled up anytime when it's required. That is when there is a disaster on the primary side goes down. So we can easily scale it up. All that we are going to do is, so you again come back to the on-prem deployment pipeline, and no change on any of the parameters. You just only select this Helix DR pipeline, and this time do not select the scale down option. So when the scale down option is not selected, then the Helix DR pipeline is going to run in scale up mode, which is it's going to basically configure the replica count. For all those services, as per our deployment sizing, right? In Helix ITSM, we have sizes, right? Compact, small, medium, large, and each size defines the number of replicas for each services. So based on that sizing, it's going to configure the replica counts for the services and bring up all the services in the namespace. And then once you go and run the get parts, you're going to see the exact, once that is done, so you can see all the stateful set and deployment has the exact number of replicas configured. And the get part will also show you the actual port terms. And how that happens is it also does the Helm deployment only. So when we run the Helix DR pipeline in scale-up mode, it is going to run the Helm install with upgrade mode, so that the number of replicas is reconfigured according to the Helix ITSM sizing, right? So that is once that is done, so you will see the services up and running. And as Nisha pointed out earlier, the only additional step after running the Helix DR pipeline in scale-up mode is to go and configure the trigger the FDS delta indexing, because as we already saw, the ITSM database backup might be ahead of the Elasticsearch backup, right? Because the Elasticsearch backup is always little 30 minutes or 40 minutes. We lost the data when the disaster happened, and then we restored the Elastic, the last successful backup, which could be 30-40 minutes ahead of the actual disaster point, right? But the ITSM data being it's continuously getting replicated from primary to secondary, so there's a high chance that we have the data up to the disaster point. So to just fill up the gap of the FDS indexing, so we can trigger that from the Meteor. You go to this system group console, and from where you can select the FDS management and the same screenshot what Nisha had shared before. So here you can specify the reindex timestamp. For example, if you had restored the Elastic backup of 2 p.m. on a specific date, select that and then reindex. So it's going to do the delta indexing from ITSM database to the Elasticsearch. So that's pretty much it for the Helix DR pipeline execution from my side. Thanks, Samantha.
Okay, so that concludes our presentation and shared session today. So I know we've got a couple of questions still in the Q&A. So I can see, Don, you're answering Andreas's one. Can we take that question? I think you've just completed it. If you could just pick up on that while I give the opportunity for the audience to unmute themselves. Could you just pick up on that question? Can you hear me, Don? Your question from Andreas about ITSM, if you could just go through that for the rest of the customers.
Yeah, absolutely. So the question was, it sounded like a technical question about the ITSM database and its need for using the same alias and the requirement for a secondary network. So the answer to that is that when you're planning for failover, you should absolutely have your database on a separate network, because if that network was part of your outage, you don't really have an effective failover site. So you do need to have networking between the two networks so that you can do data replication. But in the event that that data center goes out and you lose the replication there, then you should be able to promote that secondary standby database to now act as a primary, and then when the application points to it, it'll operate as if it was always the primary in that case.
Thank you, Don. Andreas, does that answer your question? I believe you've just come off mute.
Yeah. Hi, everybody. Yeah, I think so. Yeah, it's just the question. We have a running primary system, and there's already data in the ITSM database. And now we want to set up a disaster recovery, and we need to install the second system. And for that, I need a database with the same alias. And I don't want to install into the running database. So that's why I asked if you need an isolated network, so that we make sure we are installing into the secondary database. But I think that
absolutely.
Yeah, that's the case then. So we need two databases, and then after the installation, I can delete the second database, which I just used for installation, and then point the system to the standby database of the primary site, right?
Well, okay. So the way you shouldn't look at it as an interchangeable database, right? You're going to have the two databases up at all times, and depending on which technology you're using, they'll have different ways that they accomplish the replication and setting up a standby. So the idea is that the second database cluster is going to be in a standby mode where it's receiving replicated data, and eventually, hopefully never, you may have to promote that standby to operate as a fully operational database because your primary is no longer online. It's gone down with your primary data center. So that secondary database should never be scoped to be used with the primary data center and the primary data center application. It should be scoped to only be used with your failover site so that it has a tight coupling.
Okay, and that means for the initial installation of the secondary system, I need an empty database.
No, so for the initial installation of the secondary DR setup, right? At that time, definitely you need to plan to set up the secondary database and configure the replication, but that database will not be used when we run the DR pipeline, because the DR pipeline just deploys the Kubernetes artifacts like the Helm charts and stateful set, right? And it does not really connect to the secondary database at that time itself. But however, yes, when you plan to set up the secondary DR site for ITSM, you should set up a secondary database and get the replication configured from primary. However, the pipeline itself is not going to connect to your secondary database during the DR pipeline execution.
Okay.
Yeah,
understood.
because it just deploys your artifacts, right? And the pod is not going to start at all. So at that time, there's no requirement for a connection to the database, active connection. However, yes, the database, secondary database should be set up and replication should be started from primary so that it is available anytime for a switchover.
Okay, thank you.
Thanks, Andreas. So we have a hand raised. Kaiser, I don't know if you want to come off mute. Is it related to the question you put into the chat as well? Can you hear us?
Yeah, so I was wondering if this can be a automatic failover instead of having the manual backup and then restore. It's going to take time to get the DR site up and running. So why can't this be an automatic failover? Because if we already have the databases in 2 data centers as part of the always on feature server group, and the data is already replicated on the database level. So why can't we have this an backup and failover?
So not all the technology that we incorporate in the application supports an active type of setup. That limits us to the capability of an active passive architecture. And we do have some projects scoped this year where we're doing some research and development on in order to decrease the amount of time that would be taken in this type of passive failover mode. But this is our first iteration, and this was what we were able to use, gluing together the tools that were related to all the different components in a way that the product distributors envision their backups being used.
Currently, we are using 20.02, and we are using like 2 sites, and they are auto failover. So we have global load balancers on top of the 2. If one goes down, it automatically switches over to site B without any manual intervention. And then when the prime site comes back up, and we are automatically back onto primary site. So why can't we set up the same kind of architecture in the new versions?
So like I just expressed, not everyone's using technology that's going to support active, right? We also have to consider the re-indexing time that goes into the Elasticsearch instance. where we use the snapshots in order to decrease the amount of time that goes into that. So,
if we want, can we
reality.
have active? Can we have active for Elasticsearch?
You would have to. So we would not be with the current setup. We do not have a proposal that would be what we would consider secure networking between the two clusters to do that. But that is part of the scope that we're working on this year to enhance the current solution and continue to iterate on it.
Okay, so which version we are expecting to have this?
So we're in research and development. There's no commitment to release, but it's high will to release it when it's ready. There's several components of technology that we need to validate to make sure that they're going to be usable.
And correct me if I'm wrong, Don, this information does go out to customers when we start doing releases, as long as they're signed up to notifications.
I'm not familiar with all the communication chains. I would assume yes.
Okay. Is it something also that we would recommend, this is an open question, that when obviously customers have got features or requirements, do you want that put into an idea, or is there any recommendation, although you're talking about it actually being something that's in the pipeline with no scheduled dates? Are we wanting customers to register this, or is this something you can take away from today's session?
I would just say that we're in strong agreement in what we want for the product. It's just a matter of engineering a solution that's going to work and maintain a level of security that's fitting for all our customers.
Okay, great, thank you. So we don't have any further questions. I don't know if obviously we've gone over the hour. If there's any other questions that the rest of the attendees have, feel free to ask over the next minute or so. Otherwise, we will close the call. Everything that's been prepared today, we will send out a YouTube link which will have the recording on. The slides will be shared, and obviously the Q&A will capture all in one blog post, and we'll share that with you, which will be in the next day or so. If there are any other questions around the topics that have been discussed today, please take a few minutes to fill in the survey, because we're always looking for content coming up, and we're also looking to produce new stuff. So if there's anything that will be useful to you as a customer, and you think also for other customers, then we will start looking at scheduling some more webinars. It's likely to be now June, because we've got quite a lot booked in now for May. So if there isn't any further questions, thank you to the panelists, thank you to our presenters today for sharing this content. We hope you found it all useful, and we'll look forward to seeing you on the next webinar. Thanks, everyone.
Thank you.